Welcome to the Explainer. Today, we're going to dive into TeamCity. It's a super powerful continuous integration and deployment platform from JetBrains. You probably know them. They're the folks behind awesome tools like IntelliJ IDEA.
You know, in software development today, it feels like there's this constant race. Teams are pushed to ship new features faster and faster. But at the same time, you can't sacrifice quality. So that creates this huge challenge. How do you possibly move that fast without, breaking things?
And this is exactly where the idea of continuous integration and continuous deployment, or CI/CD for short, comes into play. Honestly, it's the bedrock of modern DevOps. So what's the big idea here? Well, at its heart, CI/CD is all about automation. By automatically building your code, running all your tests, and deploying applications, you create this incredibly fast and reliable feedback loop. It means developers can find out if their changes work in minutes, not days. They can catch bugs and issues way before they ever get near production.
Okay, so how does TeamCity pull all this off? Well, its architecture is actually pretty simple, but it's incredibly powerful. You can think of it as a brain and workers model. First up, you've got the TeamCity server. This thing is the brain of the whole operation. It's your central command hub. It manages all your project setups, it connects to your code in Git, and it's the one that decides, okay, time to kick off a new build. And then you've got the brawn, the build agents. These are the worker machines, the ones that do all the heavy lifting. They grab jobs from the server, compile the code, run the tests, and push out the deployment. The cool part is you can have tons of these agents running on different operating systems, so you can build and test for any platform you want, all at the same time. This visual really lays out that whole automated loop perfectly. It all starts when a developer commits some code. The server sees that change and immediately triggers a build. Then an available agent grabs the job, does all the work, compiling, testing, you name it, and sends the results right back to the server. The developer gets feedback almost instantly. It's just a beautiful, seamless flow.
All right, so we get the architecture, but how do you actually, tell TeamCity what you want it to do? Well, it all boils down to a few key building blocks.
So everything starts with a project. Think of it as just a big container for your work. Inside that project, you define your build configurations. These are basically the recipes for your automation, like run all the unit tests or deploy to the staging server. Each of those is made up of individual build steps, the actual commands that get executed. And finally, you have triggers. They're the spark that kicks the whole process off, telling TeamCity when to run, like, say, after every single code commit.
And here's a perfect real-world example of a build step. This little command is just telling Maven, a super common tool for Java projects, to clean everything up and package the application so it's ready to go. See? It's that simple.
Now, this is where things get really interesting. Let's see how you can combine these simple blocks into features that make TeamCity an absolute powerhouse for big, complex companies. We're going way beyond the basics now.
For instance, you can use build chaining to create these really sophisticated pipelines where one build success triggers the next one. You can slash your feedback time by running tests in parallel across a whole farm of agents. And to be really efficient, you can set up cloud agents that literally spit up on demand in AWS or Azure to handle a rush, and then just shut down to save you money. Oh, and templates? They let you define a process once and reuse it across hundreds of projects. Super powerful stuff.
Now here's a massive differentiator: how you manage all these configurations. Sure, TeamCity has a great UI that's awesome for getting started. But the real power comes from something called pipelines as code, using the Kotlin DSL. This lets you define your entire build process in a code file that you can check into Git, review with pull requests, and reuse across your whole company, just like you do with your application source code. It's a total game changer. So with all this power, it kind of makes you wonder, why do some of the biggest and most demanding companies in the world, we're talking tech giants, government agencies, why do they trust TeamCity? Well, it's because TeamCity is built on an absolutely rock-solid foundation. We're talking serious security, with things like role-based access and secret management. It has deep integrations with all the tools you're probably already using, like Jira and Docker. And it's got this massive ecosystem of over 400 plugins, so that you can extend it to do almost anything you can imagine. And honestly, the proof is right there in the names. When you see organizations like NASA, HP, and VMware relying on TeamCity for their mission-critical work, well, that speaks volumes about how stable and reliable it is, especially when you need to scale.
when you put it side by side with the competition, you can really see where TeamCity carves out its own space. Just look at that configuration row. It's one of the only tools that gives you both a really friendly UI and a modern, powerful code-first approach. And when it comes to enterprise support, having JetBrains behind it is a huge plus for big companies. It really hits this unique sweet spot between being easy to use and incredibly powerful.
So to really get the most out of it, you'll want to follow a few best practices. For sure, use the Kotlin DSL to version your pipelines. Use templates so you can stay dry, don't repeat yourself, and keep things consistent. And definitely integrate code quality tools so you're not just shipping fast, you're shipping good code. At the end of the day, it becomes really clear that TeamCity isn't just another CI/CD tool. It's a whole engineering platform built from the ground up to help software teams move fast, operate at scale, and, actually succeed. So as we wrap this up, I'll leave you with one final thought. Take a good, hard look at your own team's process and ask yourself, is your pipeline really ready for the speed and the scale that today's world demands?